Next topic is normals. So we've talked about how to compute the normal of a surface, right? So we've said if we have a triangle, we talked about this when we talked about linear algebra. If I have vertices 1, 2, 3, I can find an edge side by subtracting the two vertices, another edge by subtracting the two vertices. And then if we take the cross product, we get the normal. And here we see we've divided by the length of the normal, because it's pretty common in graphics to say the normal should be a unit length rather than just being arbitrary. The direction will be the same, right? This isn't changing the direction, it's just changing the magnitude. So we normally talk about the normal as being unit length perpendicular away. Now the way that we choose these vectors is going to control the sidedness. So if we choose clockwise or counterclockwise, it's going to flip which side we get the normal. So here we went 1, 2, 3, we get this normal. Here we go 1, 2, 3, we're going to get that normal. And this is why I earlier said the ordering that we specify the vertices matters, because it's going to affect which normal gets calculated. And that normal is going to be another 6 weeks before we get there, but that normal is going to be used for lighting. And in the lighting, we're going to, if we get our surface facing away from the light, it's going to turn black. Okay, this is well defined mathematically. So this is linear algebra. This makes sense. If I have a planar object, that object does have a normal. We typically have this in graphics. So I have this object, and I said that in our buffers, we specify the vertices. So I never specify a face. That's not something that I really send to my graphics card. I send the vertices to the graphics card. So I'm going to have to send the normals at the vertices also. So here I've got a vertex, and there's a normal here. So now what's up? This is confusing. Now, if you go to your math class, your math professor is going to say, there's no normal here, right? A normal is defined is orthogonal to the tangent plane, right? And when I have a plane, I have a tangent plane. But here I have a discontinuity. There's no derivative. So therefore there's no tangent plane. So therefore there's no normal. So it's undefined, all these creases on all these points. And in some sense, since we've approximated everything by triangles, exactly the places we have to specify the normals in graphics are not mathematically defined. They have normals. So what's up? What are we going to do about this? In fact, we do something about it. So here's a picture. So here's face normals. They're called face normals when we do it on the triangles. These are the ones that have mathematical definitions. But there is also a notion of vertex normals. So this is a picture from a drawing package, Blender or Maya, one of these kinds of packages, right? And they're showing that each vertex, I have a set of normals from the faces, which are sharing that. So I have a whole bunch of normals that could be true at that vertex if we said that we're going to set the normal to just be whatever the neighboring faces are. What we do in practice is we end up taking an average. So here's a construction. We have a normal on this face, a normal on this face, a normal on this face, a normal on this face. We're going to average them all together and say that's the normal here. So that's what we mean by vertex normal. So a face normal is the normal which has mathematical definition on the triangle or plane. And the vertex normal is the one which we always specify our normals on the vertices. But when we say it's a vertex normal, we're usually talking about this average together. So we average together all these things to get the normal at this point. There's an additional thing going on with how normals get used, right? So in the same way we interpolated colors, right? If I specify red, green, and blue as my colors, and I draw this triangle, something has to interpolate and fill in. Interpolate, I mean the weighted average of the neighbors. We're going to talk about that in more detail in a minute. But it just means as I get closer to green, I'm more green. As I get closer to red, I'm more red. What's my weighted average in this space? Well, not just colors. Everything we specify at the vertices has to get interpolated during the rasterization stage and before we call our fragment shader. So if we specify some normals here, right, here's our face normals, and then we're going to take some averaging and we're going to specify normals here on these vertices, we have to interpolate that. So in fact, that's what happens. So if I specify a color, it gets interpolated. If I specify these two normals, the normal vector is going to get interpolated across this face so that each pixel, when we run the fragment shader, the normal that gets passed to that pixel is going to be the weighted average of what we specified at these vertex normals. So what does it look like in rendering? So here's a sphere with face normals. Here's the same sphere with, they've called it smooth shading here, but it's the vertex normals. It's these averaged you average these normals, you get something that looks like this. Here's another example of a sphere. Now, you don't always want to do this averaging. So here's flat shaded, meaning using the face normals. Here's smooth shaded, meaning using the vertex normals. And we've screwed up this corner somehow. Why? Because we had a normal out this direction, a normal this direction, normal this direction. So at this vertex, we got a diagonal normal pointing out. But that's not really what we meant here. We meant this to be a square cubey shape. And you're going to have cubes later in this class. So this is something you're going to have to get right. What you wish is that for this vertex, when I'm using it on these triangles here, I use the real face normal. I don't do the averaging. But up here, where it's meant to look like a nice smooth surface, like part of a sphere, we do the averaging so that we don't get this kind of chunky look like we see here or here or here. So should you do the averaging and normals or should you not? It depends on which object you're drawing. When I ask you to do spheres, you're going to want to use average normals. When I ask you to do cubes, you're going to want to use the face normals in order that the lighting, which we won't get to for a while, will do the right thing.